Okay, welcome to class. Welcome to class. I hope everybody is okay. We need to move on with our discussion. Okay, we need to move on with our discussion. That is okay. So today we are looking at number 13 of our work. Number 13 of our work. So we can give like a minute for others to join, just a minute for others to join, then we proceed directly with our discussion. Okay? We proceed directly with our discussion. Okay. So I hope everybody is in now. We can now proceed with our lesson. We can now proceed with our lesson. Okay, so others will join as we continue. Okay, so number 13, we are told a cylindrical pipe of 2.5 meters long has an internal diameter of 21 millimeters, okay, and an external diameter of 35 millimeters. The density of the material that makes the pipe is 1.25 grams per cubic centimeters. Okay, then we are told calculate the mass of the pipe in grams. Calculate the mass of the pipe in grams. Now this is also another very special question which cannot miss to be tested. Okay, this is a very special question which cannot miss to be tested, and it is referred as it combines grams, it combines that is a mass either in grams or kilograms, and then involves volume. It can be in cubic meters or cubic centimeters. And then another thing that is also worked together in that combination, it is density. Density can be given in grams per cubic centimeters or in kilograms per cubic meters or kilograms per cubic meters. Okay, so this one, if we have that combination, we normally, I always tell my students to use this. It is called Manevu. Manevu. Okay? That combination, we call it Manevu. That is mass, density, and volume. Okay? These ones, they work together. So when you're calculating for mass, then density, it is density times volume. Okay? It is density times volume. When you are calculating for density, it is mass over volume. And when you are calculating for volume, it is mass over density. Okay? So that is what we are using for that combination. Okay? This is what we are supposed to master, this combination of mass, density, and volume. The mass is supposed to be in grams, okay, and then volume will be in cubic centimeters, and the density is going to be grams per cubic centimeter. So the density is what is density is what determines the two. Okay, if we have the density, if we have the density in if we have the density if If we have the density in grams per cubic centimeters, then the mass must be in grams and the volume must be in cubic centimeters. Okay? The other way around is if we have the density now being in kilograms per cubic meters, then kilograms per cubic meters, then the mass is supposed to be in kilograms and the volume is supposed to be in cubic meters. Okay? I've given you this underlined to show this now. That's the combination when it is underlined, and when it is circled, that is the combination. Okay? So from there we can now check on the question. What is the question asking us for? You're told a cylindrical pipe of 2.5 meters long. Cylindrical pipe of 2.5 meters long. So we have a cylinder, a cylindrical pipe of 2.5 meters long. Okay? Has an internal diameter of 21 millimeters. So there is an internal diameter here. Okay, so there is that inner part which is hollow. And say normally the pipe, it has that hollow part where the water can pass through. Okay, so this internal diameter, the internal diameter it is given as 21 millimeters. This one, it is 21 millimeters. 21 millimeters. And an external diameter, now the external diameter, that is, we're talking of the bigger circle now. Okay? The external diameter has a measurement of 35 millimeters. Measurement of 35 millimeters. 35 millimeters. Okay? The density of the material that makes the pipe, the density is given. So the density of the material that makes the pipe is given as 1.25 grams per cubic centimeters. Okay? The question is calculate the mass of the pipe in grams. Calculate the mass of the pipe in mass in grams. Okay? Calculate the mass of the pipe in grams. Okay? So that is what we are asked here. Okay? Now we are asked for mass. According to our formula, we say mass is equal to density times volume. Density times volume. Okay? So we come and calculate the density, already we have it. It is 1.25 grams per cubic centimeters. So we already have the density. Now, when we look at the volume now, volume is what is important. We need to calculate the volume. Now the volume, there is this hollow part and there is that part which is remaining. Okay? Now we need to get the volume of this cylinder first. Okay, when we're getting the volume, we have to subtract this hollow part, isn't it? Okay, so we calculate the volume of the bigger the bigger cylinder minus the volume of the smaller cylinder. Will remain with the volume of the material there, the volume of the material used. Okay, so we have to calculate this as a closed one. Okay, and then we subtract this other volume, will remain with that. Or another alternative, we get the area of the bigger circle minus the area of the smaller circle. And then now multiply by height. Okay? So all the same, it will give us the same result. Okay? So we say volume is equal to pi r squared height. The volume is going to be pi r squared height. Okay? So we can as well just calculate this because the height is the same. Okay? We can get the area of the volume of the bigger one, the volume of the bigger circle minus the volume of the smaller circle. After getting that, then we just multiply directly with height. That will be very okay. So the volume of the bigger, the area of the circle, it's here, pi r squared, area of the circle. So we'll say pi 22/7 times r, the radius. The radius is, now the radius of the bigger circle, the diameter you are told is 35 millimeters. First, that one it is given in millimeters, and we want to change that to be in centimeters. Okay? There are so many ways, but I prefer this one, a simple way, okay, where it involves me saying, there is this Kamau had dreamt many dreams concerning mathematics. Okay, Kamau had dreamt many dreams concerning mathematics. Or sometimes they say they can use the other one, which is, I don't know, Kenya had dug many dams concerning magic. Okay, or you can come up with your own. Okay, or Kibaki had done more damage, I don't know what. Okay, there are so many ways. Okay, now this one simple way, if you move any step towards this, multiply by 10. You move any steps back, you divide by 10. Okay, so millimeters, you want to change. There is no, I'm giving you this so that you can avoid the issue of cramming. I don't know, 1 centimeter to millimeters divided by 10. You know, you don't need to cram these things. Okay, so millimeter is there to centimeters. You just move, when you're in millimeters, you want to go to centimeters, you move 1 step. That means you divide by 10. You only divide by 10. So this 35, if you want to change it to centimeters, will be 35 divided by 10, which will be 3.5 centimeters. Okay, so now this is the diameter. Remember, diameter. What we want is radius, which is a half. What we want is radius, which is a half. So a half of 3.5 is 1.75. So pi times the radius, pi r squared, 1.75 squared. Okay, that is the area of the bigger circle minus the area of the smaller circle. Okay? Now the area of the smaller circle, again, the diameter is given there as 21. If you divide by 10, this will be 2.1. Okay? If you divide by 10, will be 2.1. And that 2.1, we need to divide it by 2 to give it in terms of what? In terms of radius. In terms of radius. It will be 1.05. So here, pi, area of the other circle will be 22/7 times 1 times 1.05 squared. Now this is the area of the bigger circle, minus the area of the smaller circle will remain with this, okay? And then multiply by height to get the volume. then multiply by height. Height now it is in meters. To change it into centimeters, meters, 2 centimeters, 1, 2. You multiply by 100, you move 2 steps. So this will be times 100. It is going to be the same as 250. It is going to be the same as 250 centimeters. Therefore, the height of that cylinder is 250 centimeters. So now we take the area of this, multiply by 250 centimeters. So can you give me the result of that? Can you give me the result of that? 22/7 times 1.75 square. Okay, so that is going to be 9.625. 9.625, then minus the other one, 22/7 times 1.05 squared. Okay, so the result of this here will say it is 6.16, okay, square centimeters, because this is area of a circle times that 250 centimeters, then we get the volume. You multiply that by 250, you'll get the volume. You'll get the volume. So this is 6.16 square centimeters times 250. Okay, that is going to give us times 250. It's going to give us 1,540 cubic centimeters. Cubic centimeters. So we'll have that as our volume. We'll have that as our volume. So if we have the volume now, we can now calculate for what? We can now calculate for mass, where we say mass is equal to density. The density is there, 1.25 grams per cubic centimeters times the volume. Volume is 1,540 cubic centimeters, and therefore the mass is going to be in grams, because we say grams per cubic centimeters, volume for, in cubic centimeters, then the mass will be in grams. So that multiplied by 1.25. 1.25. That is going to give us 1,925. 1,925 grams. 1,925 grams. Okay, so that is what is expected. Any question that will be involving, for any question that will be involving density, mass, and volume, you just need to work out in that manner. You just need to work it out in that manner. And there are so many questions involved in that, because that part is really, really tested, very much tested. Okay, so is there any question up to that level, so that we can now give more examples? We can give more examples involving mass, volume, and mass, volume, and density. Mass, volume, and density. Okay. Okay, thank you. I'm told I can continue, because all is well. All is well. Okay, that's very good. So let me give another question here. Give another question that can be tested in terms of mass, grams, and mass, density, mass, density, and volume. Okay. Now this one we don't need to rub, isn't it? Because it is going to help us in our discussion today. Okay, now there's this question here that involves now like two substances. Okay, you are told a density of a substance a density of substance A is given as 13 grams per cubic centimeters. A density of substance A. So let's talk about substance A first. Okay, substance A, you're told it has a density of 13.6 grams per cubic centimeters. 13.6 grams per cubic centimeters. And that of substance B, there is substance B somewhere. Let's have it. Substance B. And that of substance B, it has a density of 11.3 grams per cubic centimeters. 11.3 grams per cubic centimeters. Determine correct one decimal place the volume of B. The volume of B determine correct one decimal place the volume of B that will have the same mass as 50 cubic centimeters of A. That will have the same mass as 50 cubic centimeter volume of A. Okay. Now, here you are told you have to understand this question very well. You are told substance A has a density of 13.6 grams per cubic centimeters, and then substance B, it has a density of 11.3 grams per cubic centimeters. Volume of substance A is 50 cubic centimeters, and the volume of substance B is not known. But you're told what volume of substance B will be equivalent to the mass of A that will have a volume of 50 cubic centimeters. So what volume of A that will be equivalent to the mass of that will have the same mass of that of substance A if its volume is 50 cubic centimeters. So in this case, you're told the mass to be the same. The mass to be the same. Mass is the same mass. Okay, so that means we just need to get the mass first, so that if we get the mass, we fix it there, and then we use the mass and the density to get the volume. Okay, so here we are given density and volume, we want mass. So mass, we say it is density times volume. Okay, so we say mass is equal to density times volume, where the density of this is 13.6 grams, 13.6 grams. Okay, and then times the volume. The volume of A will be 50 cubic centimeters. This is 13.6 grams per cubic centimeter. Okay, so definitely the mass which you're going to get will be in grams. The mass will be in grams. Therefore, we have 13.6 times 50. 13.6 times 50. We'll get 680 grams. You get 680 grams. Okay? So from there now, 680 grams, then that should be the same mass, 680 grams. It has to be the same mass of 680 grams. Then we can get the volume. We can get the volume. Volume, we say volume is mass over density. Mass over density. So the mass there is 680 grams over density. Density is 11.3 grams per cubic centimeter. So we can get the volume. Okay. So that divided by 11.3. So that is going to give us 60.18. 60.18 cubic centimeters, because that is volume. Okay, 60.18 cubic centimeters, and that it means it is volume. Okay, so let's have at least one more, then you can look for more examples on your side to do. And these questions are very, very important because we cannot fail to be asked about these questions. Okay, and you need to be very much familiar about. You see, paper one is the paper that most of the people fail, but it's only that they have not understood what is tested there. Okay, but it's not a difficult paper. It's not a difficult paper. In fact, paper one you can get even up to 100 marks, because mostly it just deals with Form 1 and Form 2 work. Basically, it's Form 1 and Form 2 work. Okay, all these things we're discussing here, the issue of grams, density, this is just from one work, okay, which you've forgotten in one way or the other, and then now it brings a lot of confusion when you get to higher levels. Okay, so I have this other question here. I want us to check on it, and then I'll give you one question on your own, just within the lesson. Now you work it out on your side. Okay. Okay. Now this question, it covers like two things at the same time almost. Okay, the issue of ratio, and at the same time the issue of mass, volume, and density. Okay, mass, volume, and density. Okay. Um, okay. Let's. I wanted to give that to your slide. You do it. So let me check another question so that I can give you a small challenge on your side. Okay. Um, we have so many questions of this kind. Uh, okay. This one, sometimes these questions can even involve some ratios like this. Bronze is made by mixing molten copper, tin, molten copper and tin. Bronze is made by mixing molten copper. Bronze is made by mixing molten copper and tin. Okay? We're told if 100 kilograms of the mixture contains bronze, if 100 kilograms of the mixture contains bronze and tin in the ratio, okay, by mixing molten copper and tin, okay. So if 100 kilograms of the mixture contains bronze contains bronze and tins in the ratio 4:1. In fact, it contains copper. It's supposed to be 100 kilograms of this mixture. It contains copper and tin in the ratio 4:1. The ratio 4:1. Calculate the density of the bronze. Calculate density of the bronze. We're told calculate the density, calculate the density of the bronze, calculate the density of the bronze. If the density of copper, if density of copper, if density of copper is given as 8,900 kilograms per cubic meters, and density of tin, density of tin is given as 7,000 kilograms per cubic meters, okay. So this question you are told calculate the density of the bronze. Calculate the density of the bronze. If the density of copper is 8,900 kilograms per cubic meters, and the density of tin is 7,000 kilograms per cubic meters. Okay, so and at the beginning here, you're told bronze is made by mixing copper and tin. Okay? And we're told in 100 kilograms of the mixture, the ratio of their masses is 4:1. The ratio of their masses is 4:1. So can we calculate the density of the bronze? Can we calculate the density of the bronze? Okay. Now, here you have to be very keen. This is a very technical question as far as density, mass, and all that is concerned. Okay, it's a very technical question. Why am I saying it's a technical question? It's because when you're looking at this, we can get the mass here in terms of ratio. Mass, if we have the mass, we have the density, okay? And then what is being asked is density again, okay? What is this all about? Now you need to know that when we are mixing substances of different density, okay, and different masses, Okay, to get one density, what is important is you have to go by this formula, where we say density will be equal to the mass 1 plus mass 2. Okay, divide by volume 1 plus volume 2. Okay, so to get now liquids with the different densities, different masses, okay, but we want to know now what is the density of the mixture. To get the density of the mixture, then we need to get the mass of one plus the mass of the other, okay? Like here, we need to get the mass of copper, okay, and then we add it to the mass of tin. Of course, here the total mass is 100 already we are told. So the combined mass of the two is 100. There's no need of calculating again. But we'll calculate each mass. Why? Because we'll use this mass and their density to get volume. Because we need to get the volume of copper and also to get the volume of tin. Okay, we'll need mass 1 plus mass 2, volume 1 plus volume 2. We add them together, divide, we will get the total combined density. Okay, so let's do it very fast. Time is not on our side. So mass 1 and mass 2, the mass of copper will be the same as this is 4 over the total ratio. 4 plus 1 is 5 times 100. Okay, so that is going to give us what? 4 over 5 by 5, 1 by 5, 20. It is going to give us 80 kilograms. 80 kilograms. And the other one, tin will be 1. 1 over 10 will be 1 over the total 5 times 100, and that is going to be 20 kilograms. Okay, those will be their masses. And then now we need to use the mass and the density to get the volume. So the volume of copper first. Volume of copper. Volume for copper, we know volume is equal to mass over density. So the mass of copper is 80 over the mass of what? Tin. It is mass of copper over the density of copper, which is 8900. Okay? So that is going to give us now the volume. The volume, which is 80 divided by 8,900. So the volume is going to be 0.00898, okay, cubic meters. We can even change it into fraction for easy calculation. So we'll have 4 over 445 cubic meters, because volume is in cubic meters. Okay, and then the volume of the other one, the volume of tin. The volume of tin will be the mass 20 divided by the density of tins, 7,000. Okay, so that is going to give us 20 divided by 7,000. That is going to give us 1 over 350. 1 over 350 cubic meters. So we have the two volume and we have the two masses. The mass, the total density now, we can say the mass is 100, and then divide by the volume. Volume 1, which is 445, plus volume 2, 1 over 350. So the total density there, we can say The density, total density will be 8,441.73 kilograms per cubic meters. So the total density